Assalamualaikum and hi semua. So let us continue with chapter 2.2 calorimetry. Okay, so there are 3 learning outcome for this subtopic. The first one, you should be able to define what is heat capacity and specific heat capacity. And the next one, you should be able to calculate the heat change in constant volume calorimeter or bomb calorimeter. And then lastly, you should be able to calculate the heat change in constant pressure calorimeter, and that is simple calorimeter. Okay, so when you do your calculation, you need to use stoichiometry to compare your thermochemical equation. This concept is just like chapter 1 masa kamu SEM 1 hari tu. Okay, so next kita pergi terus kepada calorimetry. Okay, so there are 2 terms here, calorimetry and calorimeter. Okay, so calorimetry is a method used in laboratory to measure the heat change of a reaction. Okay, calorimetry is a method ataupun teknik yang digunakan dalam lab untuk measure heat change of reaction. Okay, and the apparatus used to measure the heat change is what we call calorimeter. Okay, so dia dua benda yang berbeza lah. Okay, and then kalau kamu perasan dia kalori. So kalau macam kalori dalam makanan tu, berapa kalori nasi lemak, berapa kalori burger, semua tu dikira menggunakan konsep calorimetry lah. Okay, so there are 2 types of calorimeter. Okay, so the first one is simple calorimeter, this one, and the next one is bomb calorimeter, which is this one. Okay, so for simple calorimeter, you can see lah memang sesuai dengan nama dia, memang simple pun. Cara pembinaan dia pun simple, because simple calorimeter is made up of styrofoam cup. Okay, styrofoam cup ni cup yang polystyrene yang putih tu. Okay, so and then ni ada stirrer, ada thermometer. Okay, and then kalau untuk bomb calorimeter more complicated. Okay, dia ada penutup dinding dia, and dalam ni maybe ada water, maybe tak. Okay, so this is where the reaction berlaku. Okay, alright, and then next kita kita go further to simple calorimeter. Okay, so simple calorimeter is suitable for measuring enthalpy changes that take place in aqueous solution. That's mean if you want to check delta H for aqueous solution, you can use simple calorimeter. Okay, and tadi saya cakap this simple calorimeter is made up of styrofoam cup. Kenapa dia guna styrofoam cup? Sebab this styrofoam cup insulate the reaction mixture from the environment. Okay, please change the word surrounding to environment. Actually surrounding tu termasuk environment lah, tapi saya tak nak kamu keliru. Okay, so please use environment. So maksudnya dekat sini, heat of reaction yang berlaku di dalam ni kekal di dalam solution ni sahaja. Dia tak terkeluar ke udara, keluar kiri kanan, tak. Okay, so we can assume that no heat loss to the environment. Tak ada heat loss to the environment sebab kita kan ada penutup. Okay, and then styrofoam cup tu menghalang heat from this reaction daripada keluar. Okay, untuk calorimeter, konsep dia yang sangat penting adalah yang ketiga ni, yang point ketiga ni. Dalam calorimeter, kita assume that heat cannot be, heat is a form of energy lah. So energy cannot be destroyed. So maksudnya heat released by this reaction here, tak kisahlah reaction apa yang dibuat pun. Okay, so heat released by this reaction is actually absorbed by surrounding yang ada, sama ada solution tu sendiri ataupun calorimeter tu, bergantung kepada soalan lah. Okay, so heat released by the reaction is absorbed by the solution and calorimeter. So over here kamu boleh nampak lah kita ada 2 jenis surrounding kita. Okay, solution dan calorimeter. Dia depend pada soalan. Kadang-kadang kita punya surrounding calorimeter sahaja, kadang-kadang solution sahaja. So tengok data soalan tu dia bagi macam mana. This one kita akan go further nanti bila kita buat example. But for now, please remember heat dalam calorimeter tu dia tak terbebas keluar, tapi dia diabsorb oleh surrounding yang ada dalam tu, sama ada calorimeter atau solution. Okay, atau kedua-duanya. Alright, and then next one is bomb calorimeter. Okay, so for bomb calorimeter, as you can see, there are 2 types of bomb calorimeter, the one with water and the one without water. Okay, so apa specialnya bomb calorimeter? Bomb calorimeter is used to determine enthalpy of combustion more accurately. Okay, so lebih tepat lah sebab kamu boleh compare dua ni. Ini dia punya heat tu insulate very well dekat dalam ni kan. So that's why kita kata data yang kita dapat from bomb calorimeter is more accurate than simple calorimeter lah. Okay, and then when using bomb carrier with water, okay, kalau kamu guna yang with water, so you can guess lah what is the surrounding. Okay, kalau reaction tu berlaku di sini, okay, and surrounding ni ada dua lah, iaitu water dan calorimeter. Tapi kalau eksperimen tu is carried out in bomb calorimeter yang without water, so heat released by this reaction is actually absorbed by this calorimeter only. Okay, so that's why di sini dia tulis when bomb calorimeter with water, heat released by the combustion, which is the system, is absorbed by both water and metal part of the calorimeter. Tapi kalau without calorimeter, sahaja yang akan absorb heat release daripada reaction tu. Okay, alright, and then next, before kita start kita punya calculation, kita kena tahu juga heat capacity and specific heat capacity. Okay, so heat capacity, the symbol is C besar, capital letter C. Okay, maksud dia adalah the amount of heat required to raise the temperature of a given quantity of the substance by 1 degree Celsius. So kiranya heat capacity ni bagi tahu kamu berapa banyak heat energy yang diperlukan untuk tingkatkan suhu substance tu by 1 degree Celsius. Okay, so that's why the unit is joule per degree Celsius. So berapa banyak energy yang diperlukan untuk tingkatkan suhu sebanyak 1 degree Celsius. Okay, next one, specific heat capacity, small letter C. Specific heat capacity adalah the amount of heat required to raise the temperature of 1 gram of substance by 1 degree Celsius. Okay, ini sesuai lah dengan perkataan dia, specific, dia lebih detail. So, berapa banyak energi yang kita perlu untuk tingkatkan suhu 1 gram substance by 1 degree Celsius. So, that's why unit dia joule per gram per degree Celsius. Okay, so kita tengok example dekat bawah ni. Dia kata, if the specific heat capacity of water adalah 4.18 joule per gram per degree Celsius. So, maksudnya daripada nilai ni kita boleh dapat kata, untuk naikkan suhu 1 gram water by 1 degree Celsius, kita perlukan energi sebanyak 4.18 joule. Okay, so dia kata this means that 4.18 joule of energy is required to increase the temperature of 1 gram of water by 1 degree Celsius. Okay, so benda ni bukan benda yang sangat asing dengan kamu, benda yang agak simple untuk kamu faham. So please make sure kamu faham the meaning behind heat capacity and specific heat capacity. Okay, and the major difference is the unit lah. Okay, this one joule per degree Celsius, this one specific dia ada mass. Okay, dia ada per gram. Alright, and then next. Okay, so dalam calorimeter, basic principle dia adalah heat released by reaction equal to heat absorbed by surrounding. Okay, so maksudnya heat released by reaction tu akan diabsorb oleh surrounding. Tugas kamu adalah untuk identify apa jenis surrounding dia. Kalau ikut yang tadi, macam kita dah revise sikit, kita kata the surrounding may be the calorimeter, okay, or water, or solution kan, ataupun kedua-duanya sekali, ataupun calorimeter and water, ataupun calorimeter and solution pun boleh jadi surrounding dia. Okay, and then ada dua formula, Q equal to MC delta T ataupun Q equal to C delta T, MCAT or CAT. So, bila kita nak pakai this formula, depend on the data given in the question. Okay, so kalau kamu tengok beza dua formula ni adalah, C ni adalah specific heat capacity. Okay, baru kita belajar tadi kan, specific heat capacity. While this capital letter C is heat capacity. Okay, and we know that the major difference is the unit. Okay, specific heat capacity is joule per gram per degree Celsius. So heat capacity is joule per degree Celsius. Okay, since specific heat capacity ada gram, okay, ada gram here, so that's why dia ada M dekat sini. Okay, so M ni adalah mass, okay, in gram. Alright. Kalau untuk heat capacity sahaja, dia joule per degree Celsius, dia tak ada mass dalam ni. So unit dia Q equal to CAT sahaja. Q ni adalah heat release lah. Q can be heat release or heat absorb. Okay, so Q heat release or heat absorb by reaction, M is the mass, C kecil specific heat capacity, C besar heat capacity, delta T adalah temperature change. Okay, change in temperature. Okay, tips dia senang je. If the question provide you with heat capacity, capital letter C, then you need to use CAT. Okay, tapi kalau soalan tu provide you with, betulkan this one, saya tercopy benda yang sama, provide you with specific heat capacity, small letter c, then you need to use Q equal to MCAT. Okay, so ingat, kalau dia bagi C kecil kan specific heat capacity ada gram, so make sure guna MCAT. Kalau untuk ini heat capacity, okay, so tak ada gram, so guna CAT. Alright. And then next one, tadi saya dah cakap surrounding may refer to calorimeter itself, okay, ataupun water sahaja, atau solution sahaja, atau water dan calorimeter. So kayaknya ada 3 possibility of surrounding kamu lah. So you need to choose which one yang sesuai dengan soalan dan data yang diberi dekat kamu punya soalan lah. Okay, and then kalau formula, okay, formula ni saya tak suka kamu hafal benda ni macam ni tau. Okay, nanti saya akan ajar kamu cara untuk identify apa surrounding dia, and from surrounding kita tengok data yang dia bagi. Kalau dia bagi data specific heat capacity, kita pakai MCAT. Kalau dia bagi heat capacity, pakai CAT. Easier that way instead of kamu hafal ini blindly dan kamu akan blur. Okay, cuma saya nak cakap jugalah sini, as you can see ada MC, CC, apa benda ni kan. Okay, small c ni, ya, subscript C ni adalah untuk calorimeter lah. Okay, MC tu maksudnya mass of calorimeter, CC ni specific heat capacity of calorimeter. Okay, and then kalau yang W ni pula untuk water lah. Okay, as for solution. Okay, so let us proceed with example 1. Okay, so dekat sini saya dah highlight kan poin-poin penting. So in this experiment, 0.1 gram of hydrogen and excess oxygen were compressed and placed into a calorimeter with a heat capacity of 9.08 exponent power 4 joule per degree Celsius. And then the initial temperature of calorimeter is 25, the final temperature is 25.155 degrees Celsius. And then the question asks you to calculate the amount of heat release in the reaction to form water. Okay, expressed in kilojoule per mole. So jawapan kamu mesti dalam kilojoule per mole. Okay, so ini soalan calorimeter. Always start dengan heat release by reaction equal to heat absorbed oleh apa. Apa tu maksud saya surrounding apa yang dalam example ni lah. Okay, so saya dah tulis heat release by reaction equal to heat absorbed by. Okay, so now you have to determine apa surrounding yang ada. Okay, so as you can see, this question dia bagi kamu information about calorimeter, which is the heat capacity of calorimeter. Okay, so kita boleh anggap calorimeter tu sebenarnya adalah surrounding lah. Okay, so heat absorbed by calorimeter. Okay, and then we need to identify if there is another surrounding, kalau ada lah. Okay, so don't be fooled by this one. Okay, so ini 0.1 gram of hydrogen ni, walaupun dia bagi mass, but this one is for untuk kamu cari untuk per mole nanti. Dia hydrogen ni bukan surrounding. Hydrogen and oxygen tu adalah sistem. Okay, reaction yang berlaku. So maksudnya dalam soalan ni heat released by reaction equal to heat absorbed by calorimeter only. Okay. Alright, lepas tu kita nak buat pengiraan lah. So Q equal to, formula yang kita akan pakai dekat sini ada 2 formula je. Sama ada C delta T ataupun MC delta T. Okay, so CAT or MCAT. So which one yang kita nak guna depend kepada data yang diberi. So as you can see dekat soalan, dia bagi kita heat capacity. Heat capacity yang mana satu antara dua ni? Heat capacity yang inilah C besar kan. Okay, so C besar, dia unit dia joule per degree Celsius. So dia tak ada mass tau dalam unit dia. So kita akan guna CAT. So C delta T. Okay, the subscript C here maksudnya heat capacity for calorimeter. Delta T adalah temperature changes tu lah. Okay, Q ni adalah heat release by the reaction. Okay, so kita dah ada formula, then kita boleh buat pengiraan lah. So Q equal to CC kita 9.08 exponent power 4 joule per degree Celsius. Okay, and our delta T kena tolak lah. Kat sini final tolak initial. So 25.155 minus 25.000. Okay, so ini adalah degree Celsius. So Q equal to, saya dapat 14074 and the unit per degree Celsius dengan degree Celsius akan cancel out. So tinggal unit joule. Okay, so heat release by the reaction adalah 14,074 joule. Tapi soalan dia bukan minta heat release sahaja tau. Dia minta heat release tu express in kilojoule per mole. So kita kena tahulah ini heat release kita tahu, tapi untuk berapa mole sebenarnya? Adakah 1 mole ataupun less than 1 mole? Okay, alright, so kita kena kira this heat release actually by berapa mole. Okay, so cara nak kira adalah kita akan gunalah mass yang dekat sini. Okay, mass of hydrogen gas is 0.1 gram. So kita boleh cari mole dekat situ. So number of mole of hydrogen equal to 0.1 gram divide 2 gram per mole. So saya dapat 0.05 mole of hydrogen gas. Okay, so now we already have the number of mole of hydrogen. So from this number of mole of hydrogen, we need to find number of mole of water. Sebab dekat soalan dia kata calculate the amount of heat release in the reaction to form H2O. So H2O is our reference lah dekat sini. Okay, so number of mole of hydrogen is actually the same as number of mole of H2O. Macam mana saya tahu dia sama? Sebab stoichiometric coefficient sini 1, sini 1. So we can say that number of mole of H2O is the same as number of mole of hydrogen gas. Okay, and after that kita boleh calculate lah. Okay, so 0.005 mole of H2O, okay, will produce heat sebanyak 14074 joule. Tapi kalau 1 mole of water, so berapa banyak heat yang release? So heat release saya dapat negative 281,480 joule per mole. Okay, so kiranya dekat sini when we produce 1 mole of water, heat yang release adalah negative 281,480 joule per mole. Tapi soalan nak dalam kilojoule, so kita kena convert lah to kilojoule. Okay, so that is our final answer. Okay, so jom kita recap sikit. Okay, so kiranya kalau nak jawab soalan calorimeter, first thing adalah you have to identify heat released by the reaction is absorbed oleh apa. Apa tu maksudnya surrounding dia lah. Okay, surrounding ada possibility calorimeter, water or solution. Okay, alright, so tengok keadaan. And then once dah identify this heat absorbed oleh apa, next thing adalah you need to identify formula yang nak digunakan. So, ada 2 formula je, sama ada MCAT or CAT. Okay, so how to determine MCAT or CAT? Look at the data given. So ini dia bagi heat capacity C besar, so pakai CAT. Kalau dia bagi specific heat capacity, pakai MCAT. So the next thing yang kamu kena ambil perhatian adalah soalan tu minta apa? Heat release ke, enthalpy of reaction ke, heat release in kilojoule per mole ke. Okay, so sebab dia menentukan step seterusnya. Kalau soalan kata heat release sahaja without this kilojoule per mole, then your answer akan tinggal dekat sini je lah. Okay, but since dia minta kilojoule per mole, so you have to find the answer dalam per mole. Okay, right, kalau dia minta enthalpy maksudnya delta H. Okay, so this value here 281.48 kilojoule per mole is actually delta H jugalah, enthalpy. Okay, sebab unit dia dalam per mole. Okay, so example tu dia kata calculate the amount of heat release in the reaction. Okay, so soalan minta heat release. Okay, and then mass of the calorimeter. Okay, so this is something new. This question provide us with mass of calorimeter. Okay, and then the calorimeter also contain water sebanyak 1700 ml. So the initial temperature of the calorimeter, so initial temperature is 25 and then temperature tu meningkat kepada 27. Okay, so dia bagi kita lagi information, specific heat capacity for aluminium. Aluminium tu adalah calorimeter tu lah, specific heat capacity for calorimeter. Also given specific heat capacity for water and then the density of water. Okay, so macam biasa kita kena identify dulu heat released by reaction equal to heat absorbed by Okay, so since this one dia bagi banyak data about calorimeter, dia bagi specific heat capacity of calorimeter, dia bagi mass of calorimeter. Since dia bagi specific heat capacity of calorimeter, so we need to use MCAT lah later on. Okay, so now heat absorbed by calorimeter sebagai surrounding. Okay, and then we need to think of another possibility untuk surrounding juga. Since dia bagi specific heat capacity for water, so that means we need to assume water as surrounding jugalah. Heat absorbed by water. Okay, so Q yang kita nak cari. So formula tadi saya dah cakap, heat absorbed by calorimeter. Since dia bagi C kecil, so kita akan guna MCAT. Okay, cuma MC CC delta T. And then heat absorbed by water. Heat absorbed by water, since dia bagi kita specific heat capacity, so sama juga kita akan guna MCAT, just that this is mass of water, specific heat capacity of water times with heat temperature change. Okay, so mass of calorimeter is given here, so 3087 gram times with specific heat capacity of calorimeter 0.553 joule per gram per degree Celsius. Okay, delta T tolaklah 27 ni, 27.8 minus 25, so you should get 2.8. Okay, and then mass of water, so mass of water dia bagi volume. Okay, so kita boleh kira lah dekat sini. So density equal to mass over volume. So density of water is 1 gram per ml. Mass of water is the one that we want to find. Volume of water is 1700 ml. So that means mass of water is 1700 gram. Okay, so 1700 gram times with specific heat capacity for water is 4.18 joule per gram per degree Celsius, and then delta T kita sama 2.8 degree Celsius. So Q equal to, saya dapat 24676.71. Okay, so joule. Sebab apa joule? Sebab unit dia boleh tengok lah, gram per gram per gram cancel. Okay, ini cancel, ini cancel, ini cancel. So unit tinggal joule. Cuma soalan kita baca betul-betul lah. Dia kata heat release. Dia kan dia tak minta enthalpy, dia tak minta per mole. So kita assume this is our final answer lah. Okay, so heat release by the reaction is this. Okay, so beza example 1, example 2. Example 2 ada banyak sikit surrounding dia. So how to identify? Look at the data given. Okay, so for example 3, you can try to do this on your own. Okay, together with example 4, try this one and try this 2. Okay, so we will discuss the answer. Try this 3 sekali. So we will discuss the answer in the next class lah.